Good evening, all. Tell me whether we have completed first derivative test to find maximum minima. I can't remember last class concept. Did I taught you this thing? First derivative test. Point of inflection is code, yes. Okay, before we move further, just let me know. Can you hear me?
Yes, sir.
All right. So I think we have completed first derivative test because point of inflection has been covered. So in this class, we are going to study second derivative test to find local maximum and minimum. Second derivative test to find local maxima minima. So it is even faster method than first derivative, because in first derivative you have to find the sign change. Okay, and here no such steps are there. Just follow some simple steps. Step 1, find dy by dx. It is assumed that y is a function of x because you are studying all the functions in the form y is equal to fx, where one is independent variable, other is dependent variable. So you'll find dy by dx first. Second step, put dy by dx equal to 0 and find values of x from here. Now step third, now find d2y by dx square, that is second derivative, and put values of x obtained from step 2 in expression of d2y by dx square. Finally, there are three possibilities. Step 4, if d2y by dx square is negative, this implies those values of x are points of maxima. Means you will find dy by dx, put it equal to 0, you will get some values of x. And then you differentiate for the function for the second time and you put the values of x obtained from step 2 in this expression, in an expression of d2y by dx square. So there are three possibilities. Either you will get negative values for d2y by dx square, or you may get positive value, or it is possible that d2y by dx square becomes 0. So for those values of x for which d2y by dx square becomes negative, those values become points of maxima. For positive, those values of x are points of minima. Points of minima. And in the third case, this will be point of inflection, provided third derivative is non-zero. Then point of inflection. So it is written in much detail in the notes. Just to understand this part. Now, if you remember in the first derivative test also we find dy by dx, we find f dash x. But there what we do, whatever values of x we get by putting f dash x equals 0, we plot them on the number line. Then by baby curve method, we give the sign plus minus plus. And on the basis of sign change while crossing C or crossing that particular point, we find the sign change of plus to minus, then maximize there. If minus 2 plus, then minimize there, and like that. No sign change point of inflection. Now there is another way to deal with this, and that is second derivative. So since second derivative decides the sign, decides the maxima, minima, or point of inflection, that is why it is called second derivative test. Now, see, you might have heard this particular thing that d2y by d square becomes negative. Then it is maximum, but you know what is the reason? d2y by dx square is actually dy dx of dy by dx, second derivative. And if you remember, dy by dx is your slope. So basically, second derivative is rate of change of slope with respect to x. Rate of change of slope with respect to x. Slope of tangent, obviously. Slope of tangent with respect to x. So like for example, you have this function. Now, in this case, the slope is positive. Why? Acute angle. Suppose there is this point C, I want to know whether it is maxima or minima. From the graph, it is obvious it is maxima. But how? We'll find this with the help of second derivative test. This is your left hand neighborhood, this is your right hand neighborhood, and this is your exact C where dy by dx becomes 0. So when dy by dx becomes 0, you cannot be sure that it will be point of maxima or point of minima. That will be decided by the second derivative. Because if you remember, we write for maxima or minima dy by dx is 0. It is the necessary condition. Necessary condition for a differentiable function to possess maxima or minima is dy by dx equal to 0. But we can't be sure that it will be maxima only or it will be minima. So what we do? We go for the second derivative and it decides whether a particular point is point of maxima or point of minima. And that is what I'm explaining here. Like what happens? The slope is positive. Slope is positive and this side slope is negative. So when we move from left to right, do you remember we always move from left to right on x-axis, never from right to left, from smaller to higher number. So now what is happening? Your dx is positive. Why? Dx basically is the difference. Dx came from the term del x, where del stands to 0, then it changes to d. So del x means difference. So for this x and for this x, when you find the difference, obviously that difference dx will be positive. Why? Because to the right, the higher x is there. So obviously when you subtract this x, the left one from the right one, okay, the difference will be positive. And what about the change in slope? dm is change in slope. So final, you can also say that it is final minus initial value. So finally your slope is negative and initially your slope was positive, and del means difference. What do you observe? Overall the value is negative. Minus, then again minus, so minus minus subtraction is done. Okay, it will remain a negative quantity divided by positive. Overall it will remain negative. dm by dx is negative. Second derivative is negative when it crosses a point which is assuming maxima. That is why they say that if d2y by dx square is negative, those values of x are point of maxima. Same concept can be applied for minima. Okay, just change this graph. Okay, something like this. Now it is minima. Now what will happen? On the left side slope will be negative, right side slope will be positive. So just opposite will be happening. Now it will become dm by dx will become positive in this case, right? So that is why dx is always positive, because we always move from left to right. So only this thing we have to decide. And in case of minima, it will be a positive value. Then there is something called point of inflection. See, point of inflection will be understanding with 2 3 concepts. In the previous class I told you that x is equal to a is point of inflection if there is no sign change in f dash x. Okay, then it becomes point of inflection. Then we have second method. In second method, that is second derivative test, d2 over dx square is 0 and third derivative is not 0. Then for those values of x it becomes point of inflection. Then there will be one graphical approach also which we will see later. But first of all, maxima and minima, second derivative test. What you find? You find local maxima and local minima from here. And one important thing, another important thing, absolute maximum minimum. Then we'll solve some questions here. Absolute maximum minimum values of function in an interval, in closed interval. This is also important. You know what is the difference between local and absolute? I told you. Local means in a particular region, and absolute means throughout the deciding factor. Deciding factor is interval here. Okay, like for example, some interval is given a to b close. Okay, and you have to find the absolute maximum, and that also for differentiable function. For differentiable function. For differential function. Now the question is how to find absolute, because see, for local maxima minima we have understood second derivative test, first derivative test, but no test for absolute maximum minimum, because there is no test as such. Then what we do? You remember the graph? You might have observed that some local values may also become absolute. We studied a graph and there we plotted so many values of x. So few values of x which were having local maxima minima, they became absolute maxima minima as well, but it is not necessary. So what you have to do, remember one simple concept, find dy by dx and put it equal to 0. Put it equal to 0. I'm telling you a very simple approach. Find values of x from here. Find values of x from here. Say those values are c1, c2, c3 up to cn. That depends on the degree and the question that how many values of x will come. Okay. Now finally do one simple thing. Now find fc1, fc2. What you are going to do? You are going to find the values of the function at these values. If you remember, they are called critical points. And here only f dash x equal to 0. Only that part is critical. Why? Because f dash x does not exist. This will not hold here because I am writing absolute maximum minimum function, differential function. Okay. Then what else? Two more values, fa and fb. That's it. So what you will do for closed interval, you put dy by dx equal to 0, find values of x. You will get some values of x, and also you have two endpoints of interval, that is a and b. What you do? You find the value of the function at all these values, whichever is highest. Finally, whichever is highest is absolute maximum, and whichever is lowest is absolute minimum. Only that's it. Okay. Simple way to remember, find absolute maximum and minimum. Now let us do one thing. Let us solve some questions based on second derivative test and this concept. Now let us take this question first. Find local maximum minimum of fx equals 2x cube minus 15x square plus 36 plus 1. We will use second derivative test here. Okay. First derivative is already completed. So So first of all, let us find f dash x. See, f dash x and d by dx both are same thing, right? So f dash x, it is a differentiable function. So we will use second derivative test. Okay. This is 6x square minus 30x plus 36. So now you will write for local maximum minimum. What is the first thing that you should do? First derivative must be 0. This means this becomes 0. You solve this quadratic equation. It will give two values, 2 and 3. But now I cannot say that at x equal to 2 it will be maxima or at x equal to 2 it will be minima. So for that we will find the expression of second derivative, which will come out to be 12x minus 30. Now finally I'll put values of x here. That is what I was saying. You put x equal to 2, you will get a negative value. As soon as it comes negative, one thing is very clear. X equal to 2 is point of maximum, local maximum. And f double dash 3. F double dash 3 is 12 into 3 minus 30, that is 6, which is a positive value. Simple. Second derivative test is very simple. So x equal to 2 is point of local minimum. And now if you want to find the local maximum and local minimum values, okay, that I'm not going to do here. If you want to find the local maximum and local minimum values here, you put x equal to 2 and 3 there. Okay, that's it. If you want to find the points of local maximum minima, they are x equal to 2 and x equal to 3. In that, x equal to 2 is point of local maximum, x equal to 3 is point of local minimum. Simple application. Similarly, find local maximum minimum. Another example, same concept. Let us start. See, f dash x is 3x square. For maximum minima, you put f dash x equal to 0, which means 3x square equal to 0. It will give only a single value, x equal to 0. Now f double dash x, see this. F double dash x means second derivative 6x. So obviously you have to put only this value of x here. This will come out to be 0. Now, second derivative is 0. Since second derivative is 0, it is not positive or negative. Therefore, we will find third derivative. And third derivative is 6 not equal to 0. So if you remember, this means x equal to 0 is neither maxima nor minima. In fact, it is point of inflection. So I think I am saying this thing for the third or fourth time with respect to fx equals x cube. You might have even learned the graph by now. Y equals x cube. This is the graph. Okay. Also, you can say that function is monotonic increasing at x equal to 0. Another way. No maximum minimum. Another question based on this concept. Absolute maximum minimum. Absolute maximum minimum values of fx. 2x cube minus 15x square plus 36 plus 1. This is not the same question, because in that I asked local maximum minimum. Here I am asking absolute maximum minimum, and that is why there is this closed interval given here. Okay. So if you remember what I just discussed, that if you have to find the maximum or minimum, absolute maximum or absolute minimum, you should find the value of this function at those values of x for which f dash x becomes 0, critical point, and also at the boundary points. Whichever comes highest will be the absolute maximum value, and obviously lowest will be the absolute minimum. So since this is a differentiable function, just simply differentiate and find the values of x by putting them equal to 0. F dash x equal to 0. This will give you two values, 2 and 3. We solved just x equals 2 and 3. I am repeating, they are not asking local maximum minima. No need to find second derivative or anything. Okay, so what you will do? Now we will find values of the function. Now we will find the values of the function fx at x equal to 1, 2, 3 and 5. 2 and 3 are critical points and 1 and 5 are the endpoints of the interval. Now when you will put these values in the function, where you will put here in the expression 2x cube minus 15x square plus this, you will get the four values. I am writing the values directly to save time, and the values will be 24, then 29, then 28 and 56. So now it is very clear that this is the absolute minimum value. And 56 is your absolute maximum value. This is what you are supposed to do when you have to find the absolute maximum or minimum. No need to find second derivative here, because second derivative will give you idea about local maximum minimum. They are asking the absolute maximum minimum. So either it can come at these values or it can come at the endpoint. We have to check, we have to find it. So I have this question for you. Find, let me see if you can give me the correct answer. Please solve it. Find absolute maximum minimum values of fx equals 12x 4 by 3 minus 6x 1 by 3, and the interval is minus 1 to 1. Now you know what you have to do, right? Just tell me what is the answer. Solve it quickly. You just tell me what are the critical points, rest I will tell. Yes, who can tell me the critical points? See, to find critical point, you need to find f dash x only. Differentiate it. So 4 by 3 will come in multiplication. This will become 48 by 3, 16x to the power 1 by 3 minus 2x minus 2 by 3. So f dash x will be equal to 16x 1 by 3 minus 2x upon 2 by 3. Take LCM. After taking LCM, you will realize that you will find two type of points. I'm talking about critical point. Two type of point means critical points are combination of those points where f dash x is 0 or it becomes non-differentiable. So critical points here will be x equal to 0 and 1 by 8. Why? Because for 0, f dash x does not exist denominator. And for 1 by 8, it becomes 0. That is why. So now you can see clearly both of them are part of this interval. minus 1 to 1. They are clearly the part of this interval. So we need to find the values of the function at these values of x. And what is function it is given here? So f0 will be 0. Put x equal to 0 in the function. Okay, then we need to find three more values, minus 1, 1 and 1 by 8. So when you put x equal to minus 1, it will become 12 minus 1 to the power 4 by 3 minus 6x minus 1 by 3. See, whenever there is odd root or odd power, minus will come outside, and you can write it like this. Here it will behave as plus. Why? Because even power is there in the numerator. So ultimately, and 1 raised to any power is 1. So this will come out to be 18. Similarly, I will find two other values. I am writing the values. You can check it later on. F 1 by 8 will be 9 by 4. Put this in the expression of the function. Okay, f1 by 8 is 9 by 4, and f1 this will come out to be 6. From these four values you can see clearly which is the lowest and highest. Okay, so this is minus 9 by 4, 9 by 4, it is minus 9 by 4. You can check the value later on. So clearly out of these four, minus 9 by 4 is lowest, so it is absolute minimum value. And 18, which is coming at minus 1, this is absolute maximum value. So here in this particular question, it is not simply differentiable function because denominator is also there, so it can become 0, and it becomes 0 at x equal to 0, right? And that is part of the interval. So taking all these 4 points, when I calculated the value of the function, these are the absolute minimum and maximum. So these questions were on the application of second derivative test. Now in board exams as well as in your JEE main or advanced whatever, another type of questions are asked frequently and they are word problems. Especially in boards, you can expect a question of 5 marks or 6 marks, whatever is the highest mark weightage. So these questions become important for boards as well. Find the numbers whose sum is 24, and one thing I tell you, these questions, you solve these questions by second derivative test. Okay, do not think about anything else. So in that case, you will always know what you have to do. Second derivative test. In questions wherever they are asking maximum value, minimum value, okay, such type of terms are used, you will use second derivative test. However, you will have to form everything. Just interpret the information and use it to form functions and differentiate everything. Like in this case, the question is find the numbers whose sum is 24 and whose product is as large as possible. So we'll start with let two numbers are x and y. Therefore, according to the given information, x plus y is 24. This means y is 24 minus x. So basically this equation gives a relation in x and y. Now what is the question? Let P be their product. P be their product. Therefore P equals x into y. Or this implies P is x into 24 minus x after using value of y from the previous result. Now from here, it will be a question of second derivative. Why? Because what is the question? Product is as large as possible. As large as possible means largest or maximum. Now P has to be maximum. So the question is, what should be the value of x so that P become maximum? So for that, now comes second derivative test. P is acting as y here. Okay. Find dy by dx. It is 24 minus 2x. For P to be maximum minimum, put dp by dx is 0. Okay. and find x from here, which will come out to be 12. Now since we are talking about second derivative test, so now we will find d2p by dx square second derivative, which is automatically coming negative. Why? Because when we differentiate 24, differentiation of 24 is 0, differentiation of minus 2x is 2, which is a negative quantity, which shows that p is maximum. Maxima, second derivative negative, maxima will come. Second derivative positive, minima. Second derivative 0, third non-zero, point of inflection. So p is maximum when x is 12, when x is 12. And when x is 12, this implies y 24 minus x. That is, this is also 12. What is the meaning of the question? Meaning is you have two numbers whose sum is 24 and you want those numbers to have the maximum product. So if you approach this question by hit and trial, you will never reach the answer. Or if you may even reach the answer, you may not be sure that whether it is a maximum product or not. For example, two numbers can be 14 and 10. But then their product will be 140 and they are saying that the maximum product. Alright, one more thing. If someone asks you to write the maximum product, in this case, which is x into y, this will be your 144. Okay, x and y both are coming same. So if someone goes for hit and trial, then 14 and 10, 140, 16 and 8, 128, 13 and 11, 143, like that. It will take so much time, and it is also possible that you may not be sure whether it is the maximum value or not. Okay, but with second derivative, we are sure that yes, 144 will be the maximum value. So we cannot get answer like this. We'll have to use second derivative. Writing another question here. Show that of all the rectangles, these word problems are from NCERT, and that chapter is very important from board exam point of view. Last chapter of first part of NCERT. In class 12th, you have two parts, right? This is the last chapter, and this is from last exercise. Very important. Show that of all the rectangles inscribed in a given fixed circle. So you will have one more class tomorrow. I'll finish this chapter only. I'll not be starting any chapter because after that we have some vacations, right? So what you can do in these days, I have shared maximum and minimum question bank with you today, and monotonicity and tangent normal I gave you already, but many of you could not solve it due to school exams or you were busy somewhere. So you have this opportunity that during these vacations you can finish your question banks. Okay, all the three question bank level 1, tangent normal, monotonicity and maximum minima, and we can have the discussion after the vacations. And after the vacation only I'll be starting integration. And see, integration is such a unit which gets completed very soon. It is possible that in the 10 to 12 terms we may complete the complete integration. So keep that in mind, and now you have that time that you can complete your backlogs or anything that you have not done, any questions, practice or theory, whatever. Okay, so show that of all the rectangles inscribed in a given fixed, the square has maximum area. This is the question. See, what is the meaning of the question? Fixed circle, important thing. You should properly go through the question. Okay, every word is important. Sometimes we skip something and we don't know whether something is given, but we cannot interpret it. Of all the rectangles inscribed in a given fixed circle, let us draw a circle first. And when they say given fixed circle, circle is fixed. So that means radius is constant. Radius is constant or radius is given, whatever you say. And let R be the radius. Let R be the radius. Now you can draw so many rectangles inside it. Inscribed means all the vertices of rectangle are on the circle. Like for example, you can draw this rectangle. You can draw this rectangle. Okay. You can draw some another rectangle, maybe like this, and so on. So out of all these rectangles that you will be drawing inside this circle, of all those rectangles, a square will be having the maximum area. Why? Because every square is a rectangle. That is why. Every square is a rectangle, but every rectangle is not a square. So that is why they are saying of all the rectangles described in the circle, square has the maximum area. So we need to do two things here. We have to maximize the area, maximum, and we have to show that the rectangle is a square. Now let us start the question. You will come to know what exactly I want to say. We will take some rectangle. Okay, we will take some rectangle. Let us suppose write everything in exam. Okay, let x and y be the dimensions of rectangle. You won't take square from starting. You have to show that you took a rectangle, but when you maximize its area, it becomes a square. Okay, so let x and y be the dimensions of rectangle. Important thing is geometry. In these questions, like these and questions related to mensuration, formula of 3D will be used, like volume of cuboid, total surface area of cube, surface area of sphere, hemisphere. Please learn them. Okay, I'm not going to write them here. From the geometry, we can see that whenever there will be such situation that a rectangle is inscribed in a circle, then this thing, diameter of circle will be equal to diagonal of rectangle. That is obvious from geometry or symmetry also. So that is why I'm writing 2R here. And this will give us an important relation, just like in the previous question, from Pythagoras theorem, because in rectangle each angle is 90 degree. So from Pythagoras theorem we will use the result that x square plus y square is 4r square. Okay, this will be used to put value of y in terms of x. Now area, let A be area of rectangle. And how we write the area? X into y, length into breadth. And from here I will substitute the value of y in terms of x from this equation. What I will do? I will shift x square to the right side and take the root. So this will be the value of x. Why we need to do it? Why not differentiate here at the first place? Because see, in the right side there are two variables x and y. And we can differentiate only with respect to one variable. So we need to eliminate another variable. Why? How? By the help of given relation or given condition. Now they won't be giving this equation x square plus y square is equal to 4r square. You have to interpret the information and you have to write the result from your concept, or right, from your knowledge of geometry or whatever. You need to create an equation in such type of questions which are relating both the variables. Otherwise, you won't be able to solve this question. So these are very important questions. Last exercise of first part of NCRT. Last 15 questions are very important. All right. So what I have done, I have eliminated y. Now you can see in this equation, we have to maximize area, and in the right side r is constant because the radius is constant because circle was fixed. Now a has to be maximized. Question is lengthy, listen carefully. We find dA by dx first. So that means differentiation product rule will be used. Taking x as constant, we differentiate this thing, root. Differentiation of square root is 1 by 2 square root. This we learned in differentiation. Into chain rule. Differentiation of 4r square will be 0. Differentiation of minus x square will be minus 2x. Therefore, dA by dx is under root of 4r square minus x square. Here 2 gets cancelled. And this is minus x square upon under root 4r square minus x square. So dA by dx is 4r square minus x square. We are taking LCM by under root 4r square minus x square. See, these calculations make things lengthy. Otherwise, concept is limited. For A to be maximum minimum, because we cannot be sure that it will be maximum or it will be minimum only. Okay, dA by dx is 0. When you put dA by dx equal to 0, obviously numerator will become 0. Denominator will go towards right side. It will be converted into 0 only. So 4r square minus x square is 0. Here it is 2x square, not x square, 2x square. 2x square. Okay. What happens? See, let us complete this. 2x square is 4r square, x square is 2r square. Put this value of x square as 2r square in the first equation. Since x square plus y square is 4r square, you put this value here. So y square will also come equal to 2r square. That means x square is equal to y square or x is equal to y, which means rectangle is a square. In this particular case, becomes square. Why? Because if the adjacent sides are equal, then obviously rectangle will be square. Because I took x and y as the dimensions of rectangle and they are coming equal. So it will become square. Now one more thing is remaining, last thing. And that is d2a by dx square. Because till now I have written for a to be maximum or minimum and this condition is coming, right? But what about area? I need to maximize it now. So I need to show that for this value of x, okay, this value of x, your second derivative is negative. You have to show all these things in exam. You cannot skip any step, otherwise marks will be cut. So now this particular expression, we will have to use quotient rule because it is written in the form u by v. So square of the denominator, we differentiate numerator first. So there is minus 4x. We have to be careful here when we differentiate again and again. Then minus differentiation of denominator, it is minus 1 by 2 root. Then chain rule minus 2x. And then we write numerator, which is 4r square minus 2x square. Now put this value here. Put this value in this expression. Good part is that this second part will become 0. Why? Because when x square is 2r square, no, this thing will 4r square minus 2x square. This will become 0. So this second part is 0. d2a by dx square when x square is 2r square. In the denominator, I am putting 2r square in place of x square everywhere, wherever I can see x square. So it is 2r square here. In the denominator, it will be minus 4. Now see, here it is x. So that is fine, no problem, because you can take the square root and take only root 2r. Why not plus minus? Because x, y, r, they all are dimensions. So x is equal to minus root 2r. How it is possible? Only the positive value. Then inside root will be 4r square minus 2r square and rest part is 0. Rest of the part is 0. What do you observe? You observe that it is a negative value. Why? Minus is there. Rest everything is positive. Radius is positive. Square root is positive. R square is positive. Because of this negative sign, we are having negative. That means A is maximum. Like this, you have to solve in the exam. Because second derivative negative, A is maximum proved when? When it happened? When x became equal to y. And that means what? That means rectangle is a square. So what you have shown ultimately, that of all the rectangles which are inscribed in a circle of constant radius, square will have the maximum area. Okay, this is the meaning of this whole question. Okay, now there is this question 3x plus 4y equals 5, where xy belongs to R. Then find minimum value of x square plus y square. This is the question. See, with the help of this question, I want to tell you how different concepts of mathematics can be used in a particular question. Okay. This particular question can be solved by so many methods. I will try to discuss all of them. And by discussing all those methods, I want to show you that sometimes so many concepts are there which can be applied in the same question. Okay. Whenever you see minimum maximum, what you can think? Let us see. First of all, since we are studying maximum minimum, so obviously we'll start with the first process. Since 3x plus 4y equals 5, why this equation is given? So that I can write y in terms of x. Now, to this simple question, no language, simply equation is given, find minimum of this. Let us say this expression is s, as it is some addition, so let us say it is s. It has to be minimized. But before that, we substitute value of y. Okay, if you want, you can further solve it. Just simplify this if you want. So s will come out to be x square plus 25 by 16, 9x square by 16, and then 2ab. 2ab will become 15 by 8x. So finally, I can write it as 25 by 16 x square after adding these two, minus 15 by 8 x plus 25 by 16. We have to find the minimum value of this expression, right? Minima. So now we find ds by dx. This comes out to be differentiation of x square is 2x. So 2 will get cancelled by 16. 25 by 8x minus 15 by 8. For s to be maximum minimum, ds by dx is 0. This means 25x by 8 minus 15 by 8 will become 0, or x will come out to be 15 by 25, that is 3 by 5. Now we will differentiate it again. 25 by 8 automatically a positive value, s is minimum, and that is what we want. And it is become minimum when x is 3 by 5. But the question is find the value. So put this value here. Put this value here. You will get the minimum value of s, or the expression x square plus y square when x is 3 by 5. So let us put this value here finally. S minimum is x square, that is 3 by 5 whole square, plus 5 by 4 minus 3 by 4. Here x will be multiplied. Yes. Square. So this is how much? This is 9 by 25. Then this part LCM will be 20. So 25 minus 9. 9 by 25 plus 16 by 20. 16 by 20 is 4 by 5. 4 by 5. So ultimately 1 will be coming. 16 by 25. 1 is the answer. So minimum value of this expression x square plus y square is 1, subject to the condition that x and y are real numbers and they follow this equation, or they satisfy this equation. Method 1, by calculus differentiation. Now I am writing question here once again, and let me see if anyone can give me the answer. I want to solve this question by the help of vectors. Vectors. There is no vector at all. And I'm saying that I want to solve this question with the help of vectors. Can anyone tell me how? Anyone having any idea about this question and that how we can solve with the help of vectors? Because we have already completed the chapter. Yes, anyone? Actually, you will have to start by assuming two vectors. Let there is a vector formed by the numbers present here. 3 I cap, 4 j cap. I solved such type of question when I taught you vectors at that time also. And let us assume another vector B, which will be formed by these alphabets. X I cap, Y j cap. And from here, I will find dot product. A dot B. A dot B is AB cos theta, where theta is the angle between the vectors. So, in the left hand side, I write these vectors. In the right hand side, we have the magnitudes here. A and B represent the magnitude. So, under root 3 square plus 4 square under root x square plus y square cos theta. So, you will see that this is very easy method in comparison to this calculus when we talk about the calculation part. Because next step you will get the answer. You know how to do the dot product. I dot I is 1, I dot j is 0. So, you will get 3x plus 4y only, and that value is given 5 in the question. So, 5 cos theta under root x square plus y square, 5 gets cancelled. So ultimately under root x square plus y square is 1 by cos. Square both sides and that will give you the answer. That if x square plus y square has to be minimum, the denominator of the RHS should be maximum, which will be 1. And this is the answer. For x square plus y square to be minimum, since there is constant in the numerator in the RHS, so denominator must be maximum and maximum value of cos is 1. Ultimately it will be 1. So same answer is coming. 1. Okay. But I think very few steps have been used. So by vectors also. But it is the matter of practice that such things strike at the time of exam. The same question that I will not be solving actually. This question from here. Okay. I will just give you the hint. That is third method where you will change it in quadratic like this. Okay. And instead of writing this whole story ds by dx maximum minimum second derivative, you could have simply written the answer at this step only, that s minimum will be 1. But how? Because it is a quadratic polynomial. And in the quadratic polynomial, if coefficient of x square is positive, then its minimum or least value is minus d upon 4a. You might have studied this concept in class 11th. Minimum, s minimum, will be minus d upon 4a. From here only you will get 1. You will save all these steps in calculation. So that means it can be solved by quadratic also. Then maxima minima. Then here it is vectors. Method 3 is use of quadratic. Okay, I told you. Minimum value minus d by 4a when a is positive in ax square plus bx plus c. This is the concept. So there only I could have written the answer. Then I'm telling you one more method here, and that is your coordinate geometry. That also is visible, not visible here, but you should try to see things in all type of ways. Like for me, this is a straight line. Till now, which was a simple equation, now it is becoming a linear equation in two variable. Okay, and that represents a straight line. If we draw it, if we draw this line, then it will cut x-axis where y will become 0. That is 5 by 3 comma 0. And this point will be 0 comma 5 by 4. So what is the meaning of the question? Then minimum value of x square plus y square. Minimum value of x square plus y square. Let me tell you something. Now since we are looking at this question completely from perspective of coordinate geometry, so I can say that this is a straight line and there is a moving point x comma y on it. Okay, because x comma y is a point on this straight line. And why moving point? Because all the points which lie on this line satisfy its equation. So it can be any point. Okay. Now this point should be such that, now see how we are analyzing the things. This point should be such that x square plus y square is minimum. From here, from here, that minimum. Okay. I take origin 0 0. Okay. And I observe that distance of OP is under root x square plus y square. I take origin from my side and if I join O and P, then using distance formula, this distance will be under root x square plus y square. From this, it came in my mind that if this distance has to be minimum, if this distance has to be minimum, then it must be the perpendicular distance. Why? Because of all the distances from a point on a line, the shortest is perpendicular. And how we are relating these two things? Because in the question they have asked us to find the minimum value of x square plus y square. So that is why, now see last step, OP equals under root x square plus y square. And now I will find this distance OP by using the formula of perpendicular distance of a line from a point which is OP itself and the point is 0 0. So what will be the formula? A into x1 plus b into y1 plus c upon under root a square plus b square. What I have done here? I am finding the distance of the point 0 0 from the line 3x plus 4y minus 5 is equal to 0 using the formula. And why I am doing it? Because that will be equal to OP itself and OP is that expression which has to be minimized. And that is why I am saying that perpendicular distance is the minimum distance or shortest distance. So from there this term is coming minimum. When you write it, it becomes 5 upon 5 and that is your answer. Because if this thing is 1, its square will also be 1. So x square plus y square, its minimum value is 1. So now that you have studied maxima minima, it doesn't mean that you forget about all the things that you have already studied. Maxima minima, this concept is used even in sequence and series chapter. There was this topic AM greater than equal to GM. There also you find least values, maximum values. But there the limitation is that you can apply that only for positive quantities. But then whatever you have studied till now you are supposed to apply all those concepts. Okay. It is not necessary that you have to find maximum minimum by DC2 only. In objective paper, you have all the options. So obviously you need to use that method which saves your time. But this writing thing and everything, this becomes important from board exam point of view. Like that question, rectangle one, that I have completed in like 20 or some steps. Because in boards you have to explain everything, you have to show everything. Objective you are free. Just wait a minute. Let me see how many pages are left. Okay, let us complete this part also. Then regarding graphs, part will be remaining, that will complete in tomorrow's class. See, there is this topic. We'll cover two topics now. One is concavity, other one is point of inflection. And then graphs, last topic of this chapter, that will complete in tomorrow's class. So what is concavity? You might have seen that we draw graph of sin x like this. Okay. It does not depend upon our wish that we want to draw it like this. No. The shape of this curve which changes like this. Okay. And particularly the shape, that is because of the concavity, and concavity is determined by derivative. That is why this topic is also an application of derivatives. Let me tell you what is the meaning of this. See, this part we will say concave down. There is no convex here, right? And this part we say concave up. And you are already familiar with these terms, like in parabola only. Okay, this is your concave up, concave down. So these shapes are called concave up, concave down. But how they are decided that now it will be down, now it will be up? For that, we have this concept, concave up. This can be understood in two terms. First, the tangent is always below the curve. Tangent is always below the curve. And second, there are two ways to determine. Either you go for this tangent thing, or it is better if you use f double dash x. What is the meaning of this? This means that if for the domain of f, or in some interval, f double dash x is positive, then in that case, the shape will be concave up. That means the shape will be something like this. Why? Because see, if you want to draw the graph, if you want to draw the tangent here, let me draw the same thing on the right hand side here. This is your concave up. You draw tangent to it and at any point of it, wherever suits you. Suppose you want to draw it here. What do you observe? Tangent is below the curve. Let us say you draw here. What do you observe? Tangent is below the curve. You draw it here. What do you observe? Tangent is below the curve. So that is the meaning. Secondly, for such type of curves, that is concave up, f double dash x is always positive. Then for concave down, opposite happens. Concave down. Just change these definitions. Tangent is above the curve. Tangent is above the curve. Always. Second, f double dash x is negative. F double dash x is negative. Like in this case, you draw a tangent. What will happen? It will always be coming above the curve. Right? Tangent is above the curve. Point of contact is below the tangent. That is why you can say that. And point is on the curve. So you can say that curve will always be below the tangent. And what is other condition for it? F double dash x is negative. For all x. This we have already explained. F double dash x means slope, rate of change of slope. And I have already taught you this thing, minima, maxima. So same concept. Like for example, let us take an example. This will help you understand the shape of y equals x cube now. See, when we were studying differentiability, at that time I said you learned this graph of y equals x cube. I will tell you the reason later on why it is so. Right? So what is important here is this shape. Right? Concave up, concave down. So listen, let us find, this will help you understand the concavity of this graph. First derivative is 3x square. Second derivative is 6x. Here I said for all x belongs to domain of f, and if you heard properly, I also said or in some interval. or in some interval. Same applies for this. Let us see what I want to say. If x is positive, I am strictly talking with respect to this example. So listen carefully. If x is positive, then d2y by dx square will become positive in this case, and which means concave up. So that is why you can see that towards right of 0 the shape is concave up. And if x becomes negative, then in this particular question 6 times of x, that will be negative, and now it will be concave downward. So reason this is the reason behind the shape of y equals x cube. Okay. And y graph is present only in first and third quadrant. That can be explained with the help of simple coordinate geometry. If x is positive, its cube will be positive. X positive, y positive, first quadrant. If x is negative, its cube will be negative. X negative, y negative, third quadrant. That is why the graph is in first and third quadrant. Okay. And this is the shape concave up and concave down. Also, these things will be used in tomorrow's class also. When x is infinity, y is infinity. That is why graph is going like this endlessly. If x is minus infinity, y is minus infinity, it can go down. So that is why. And from the previous discussion, you already know that graph is differentiable at x equal to 0, and this is the tangent to it. You remember the previous classes. Then increasing decreasing also can be explained from here. See this first derivative dy by dx. If you remember f double dash x greater than equal to 0, function is increasing. So what do you observe here? First derivative is positive. That is why what you see, that function is always increasing. In fact, we have already calculated the monotonicity of the function at x equal to 0 for this function. It came monotonic increasing. So now everything should connect. Okay, that is important. F double dash x, its sign will decide whether the graph of the given function is concave up or concave down. And with this, I am writing the last point of today's class, point of inflection. And I told you that point of inflection can be calculated in three ways, either with first derivative test, no sign change, second derivative test, second derivative 0, third derivative non-zero, and finally, this is best. But if you need to draw the graph first, the point where the graph changes the concavity. The point where the graph changes the concavity. Changes the concavity means in sense of up and down. Changes the concavity. It's called point of inflection. So once again, we can take example of x cube. If you look at this graph of y equals x cube, then till 0, we are moving from left to right. Till 0, shape is concave down, and after 0, it is concave up. So that means x equal to 0 is point of inflection. Just look at the graph and you can tell about the point of inflection. Point of inflection in y equals x cube. Okay, concavity changes at this point. So this is the way to tell about point of inflection. So now whenever you will have a question on point of inflection, you will decide whether you want to use this graphical approach or you want to use first derivative test or second derivative, whichever suits you, you go for that. Okay, you have three ways. Now after this, only one topic, that is not a topic. Theory is complete. Theory is complete. But lastly, there is a topic where we learn to draw any type of graph. You will be able to draw the graph of any cubic polynomial, biquadratic polynomial, rational function. There will be some steps, 8 to 10 steps. We have to follow them and we can trace any curve. So that will take some time. So that is why I'm keeping it for the next class. Otherwise, everything will be mixed up. And since there is only one class after today, so we won't be able to start integration. It makes no sense. Okay. So tomorrow we are going to finish this chapter. Please go through the theory. I'm repeating. That's it. Thank you so much.
Thank you, sir.